Metaclasses 101, customizing class creation in PyCon. Yeah. How many people have experience with Django? Okay, a lot. So here's some Django code. You define a class person, essentially it corresponds to a service model. And once you've done that, you're free to do stuff like this. Person.objects.get, person.does not exist. Now, where does this does not exist and objects come from? Like, I don't see that on the class. Like, have you ever wondered where does this stuff come from? Today we're going to find out. About me, I had an introduction already, but I'm so awesome. I'm going to do it again. Studied mathematics and computer science at LAMP. Good to be back. Working as a software engineer, mostly involved with the OpenEdX project, which uses Django and React. So that's what I do at work. Interested in nerdy things. I won't be talking about metaclasses otherwise. Particularly interested in compilers, networking protocols, and recently I've also been interested in cryptographic algorithms. This has nothing to do with the recent, bull market with all the cryptocurrency stuff, but yeah. So, I'm going to assume everyone is familiar with classes and instantiating classes and creating objects. Okay, so yeah, this is 101 in Metaclasses, not 101 in Python. So here is a class, simple class. I don't think we need to explain anything here. So this is interesting. Now we can instantiate superhero, and we get S, very nicely named. And you can see that the type of S is superhero because we constructed it from superhero. What's interesting is here that the type of superhero is class type. So what this tells us is that superhero, the class here, it has been constructed with type. Okay, so essentially superhero is not just a class, it is an instance of something that is type. Right? And in fact, if you do the if instance check, superhero type, it gets true. So that's the most important thing. I think it will be the goal of this talk to see how essentially classes are objects of other classes. And okay, to build on that, or essentially to see it at another level, here's another rather simple class. And here is something that, how many people have seen something like this? Okay, some of us, that's nice. So essentially, when you write this, Python is doing something like this. It executes the class body. The class body is like whatever you put in the language. In this case, this is this function, who am I? And it calls type with the name of the class. And this empty tuple is the basis you define here. In this case, there is none, so it will be empty. And the body of the class. Okay, the body of the class is just a function, who am I? And it's going to call type with that information, and type is going to return back this class object. Okay, and whatever type returns, it binds to language, and you have that. And in fact, if you do not believe me, here's some stuff you can do with language. Okay. You can execute this part directly, and then you can see that you will be able to instantiate language. L equals language. L is a main.language object. You can call L.whoami. So essentially, there is, for almost all practical purposes, there is no difference between this stuff here and this stuff here. Okay, and so I think looking at things like this, it makes it more clear that language is an instance of this type thing, because this is like essentially how you instantiate classes, right? It's the same syntax. Okay, so like this is somewhat of an aside. We use type in two ways, so don't be confused. Both are valid. If you pass some object to type, it will return the type of the object, and if you use something like this here, it creates a class object for you. Okay. And what's a metaclass? So we've seen that classes are instances of other classes. So the class of a class is known as metaclass. Okay. Nothing more than that. And by default, if you define a class like the normal way, the class will be type. So it's like the default metaclass. Okay. Every class is constructed by type, and so type is the metaclass of almost every class you write. Okay. So far, so good. That's interesting. So the metaclass for type is type. Okay. You can do this check, okay, on type. That's okay. That's nice. Okay. So by default you get type as a metaclass. Here's how you can write your own metaclass. Okay. You define a class, you inherit from type, and here we're doing nothing useful so far, but the goal is to see how you can specify a different metaclass than type. You define a class, and like this, you can specify that, hey, you can indicate to the interpreter that I want to use the meta class as the type of B, or as the class that I want to construct B from, that I want to instantiate B from. And then you can see that B.class will be main.meta instead of something like class type as earlier. And essentially earlier we saw that we called type with the name of the class, the basis, and the namespace dictionary of the class. But when you specify that the meta class is meta, so instead of calling type to process this, the interpreter is going to call meta and pass in the relevant arguments, which in this case correspond to this. Okay. So we can have our own, we can define our own meta classes. What good is that, right? So far we've only seen that if we define our own meta class, then b.__class will evaluate this meta class. Not so good, right? So essentially, when you construct objects from classes, then the way you define that class, it impacts the objects that you create out of it. So in a similar manner, the way you define your meta class here, it will impact how B is created, okay? It will impact the properties of B, you could say. It will essentially. And so there's one very neat method, _new or _new. And you can define that in a meta class. And in fact, you can also define it on normal classes. Anybody's ever done that? No. Okay, it works roughly the same way. But you define it here, and we're just saying, okay, just print the whatever argument you get. And once Python is going to process this class B declaration, it's going to call this new method inside of the meta class, and it's going to say, hey, just give me B. So it's going to delegate the construction of B to this new method and say, do something and return B. You might as well here have returned 6, and then B here would not have been a class at all. It would have been 6. You can do that, okay? That's a crazy thing to do, but you can do that. And the signature of new is such that it gets the meta class, which is meta itself. You can see the print statement here, and the name of the class you want to construct, the basis of the class you want to construct, and the attributes of the class, which is like the namespace here. This is probably going to be empty. Python adds some stuff it needs, okay, the call name module, it might add some class cell, other things unrelated. Not really unrelated, but unrelated to our work here. So here is a very weird use case for new. Okay, don't do this. Okay. So when you construct the class, what you do is, this is the namespace of B in this case, right? This is the namespace of B, which is essentially empty because we haven't added any methods, attributes here. What you can do is you can add the magic attribute, okay? You can do it. And then you can delegate to tag._new, which is going to construct the class B. But what you find here is when you have this, when you run this, B.magic is valid attribute, okay? We input it on the class, but the meta class put it there for us. Okay. Like similarly, there's the init method you can define in a meta class. Essentially, you can define any other methods too, but these are like the methods people choose to define more of. So this is just like the init method in your class. You can initialize the object. So here you can initialize the class object. I hope it is clear. I'm just printing stuff. Nothing really crazy like earlier, but you can do crazy stuff here. You can add attributes on class inside of init. You could do the magic stuff we did with dunder new. You can do that here too, right? But you have to note that by this point, CLS, the class we want to construct, which is B, has been constructed. Okay, so it is an object, but back in dunder new, we did not have CLS, we did not have B yet, and B was constructed essentially by super dunder new. Okay, is that a useful? That's a distinction. I don't know how useful it is, like adding attributes and stuff to a class before it is an object in memory, and or adding it afterwards it's an object. It might make some difference in some scenarios, but I don't really see this one. Okay. So here's a very nice method. The dunder prepare method. So we've been talking about class namespaces and stuff, and this is not really a nice example. I should have put something in B. Like we'll see things later. So when PyCon is going to process this, it's going to look at whatever we define inside of B, and it's going to put it inside a namespace. Okay, the namespace of B. Okay. Now where does the namespace of B come from? By default, it will be the empty dictionary, okay? But if you define this dunder prepare method on your meta class, then it will call that dunder prepare and it will say, okay, give me the namespace B. Okay, I want to construct a B class, then it's going to pass B as the name in the basis of B, if there are any. And then you say, okay, give me the namespace of B, I want it. And in this case, we don't do anything useful, but we could. Okay, let's do some stuff. So the namespace is essentially a dictionary-like object. There's some restrictions, I think, not really restrictions, but you can have a different object. I think you need to define set item and get item. That's necessary. But here, let's see what we can do. So we define a node docker deck, and this deck is just like a normal deck. But if you try to add in something, a key that it looks like Docker, it does nothing. Okay, so it does not like keys with Docker in them. And so if you try to add Docker equals 1, it will just ignore that. Anything else works fine. And we define a no Docker meta class, and in prepare we say, okay, the namespace should be an instance of no Docker deck. And what happens is that here we define a container class, okay, and we say its meta class should be no Docker meta class. Okay, so that's good. So, and then we define def is Docker, is LXC, you could define is some other container runtime, anything you want. And C equals container, C dot is Docker. This Docker does not exist. You get a trace back. Why do you get the trace back? Because the namespace of this class is a no Docker deck. And when PyCon is going to add is Docker to that deck is just going to ignore it. Right? So is Docker never made it to the container class because of this weird namespace that we added. Okay. Don't do that. This is really, I'm having really stupid examples here, honestly. Don't do that. We're going to see some more real examples later on. This is just for illustrative purposes. Okay, so this is somewhat of an aside. This is essentially assumed knowledge for this talk somewhat, but I'm going to go over it. So when you do x and then brackets and adding some params, this is essentially what's callable in PyCon. So you can call x, and to evaluate that, PyCon does this thing. It evaluates the type of x and calls the dunder call on the type of x, passes in x, passes in any arguments here, you pass to x. Okay? So essentially these two things, they are equivalent. And here's an example. You define a function. Now you can call it like this. Okay, like type of the function dot underscore call and pass in the relevant argument, and you get the right results. Okay. Welcome dunder call. You can override call methods. Anybody's done that on a common class? Yeah, you can do that to make your instances callable, right? So you can define it on the meta class. Okay. So you can define dunder call, do whatever weird stuff you want to do. Okay. And then when you define a class B with that meta class meta, everything is fine. But when you instantiate B, then the code inside of this dunder call is called. You see this print statement over here. Why? Because B23 is essentially type B dot underscore call, which corresponds to this method. Right? So not only, in a way, you can think of it like not only is the meta class controlling affecting B and its properties, it's also in some way you can use it to affect how these instances get certain things, right? So you can affect the instantiation of these instances and do crazy stuff in there too. Okay, so we've seen a lot of meta class methods. You can define your own methods. You can define crazy stuff. You can define, for example, if you define, anybody who defines set item on a class, yeah, so the objects you get, you can subscript them. So if you define set item on a meta class, you can subscript the class itself. So essentially, all of this is just essentially the same things as you do with classes and instances. It's just like at one level higher. Okay.
So in this case, the meta is the meta class?
Yeah, the meta is the meta class.
And parent child are not meta class?
No, parent is a normal class, and we say the meta class of parent is meta.
Okay, and what about the child?
The child is simply a normal class which inherits from parent, and now we're going to see that it's going to get some special meta class assigned because it is inherited from parent. Let me just go to this slide and then we'll see. Okay, so now you have meta classes, and we've seen you specify them like this. Meta class equals meta. And so if you define, now parent has a meta class, a special meta class that you define. Now child inherits from parent. So will child get the same meta class as parent? And yes, that is indeed the case. So meta classes will be inherited down the chain. And the rule is that if you have a class C, the way its meta class is determined is that you look at its base classes, you get all of their meta classes, and you just like look at the inheritance structure of all the meta classes, and you choose the lowest one. Okay, that's what the language developers have chosen. Gotta make sense. So in this case, child will have the meta class meta, and you can see that by calling type child, it tells you that its class is meta. Okay, so now let's recap things. Let's see what all of this has been about. So you have a class definition, something as simple as this child here. Okay, a simple class definition. And now we want to see how it will be processed. Essentially, we've discussed all of that. Okay. So the first thing the interpreter does is it determines the meta class. I'm going to denote it by MCLS. That's how you see it in a lot of places. And then it says, okay, it's going to try to construct a namespace for the class, And for that, it's going to call MCLS render prepare, and then it's going to process the body of the class. So the functions in the body, the attributes, the descriptors, whatever you put in the body, it's going to be evaluated, and the namespace in which it's going to be evaluated is the one that's returned by render prepare. So you can think of it like when the body is processed, then the local namespace is whatever is returned by MCLS render prepare. Okay, and then it's going to call MCLS with the name of the class you want to construct, the basis, and the attributes. This attributes is like this namespace above, but it has been populated in step 3, right, with all the definitions and whatever was inside the class. Okay, so once we are here, we know that this callable syntax, we just saw that it was equivalent to the type of MCLS, render call, and all these params. And the type of MCLS usually is type itself, but you can chain metaclasses, okay, if you want to. If you want more crazy stuff, you can do that. But more often than not, the type of MCLS, in fact, in all the cases that we've seen, is type. And so it will call type render call with these terms. And what type call does by default, type is a built-in. It calls MCLS render new, which we've seen, and to construct the class, and then MCLS render init to initialize the class. So you can put special logic in here, as we have done in our examples, and get special behavior on the class. Okay, so I hope we have some idea for a metaclass, right? It's the class of a class itself. Okay. So I think now we are going to see some examples. Yeah, so some real world examples, not like our earlier ones, which were almost useless. So some stuff that you can do with metaclasses that people have done. So we saw, and right in the first slide, the Django stuff, the Django magic. This is right from the Django source. So models.model is, it inherits from model base, and since model, this is crazy stuff. Okay, this is the type over here. It needs to be metaclass equals model base. Okay. So model has the metaclass model base, and so anything that inherits from model will also have the same metaclass of model base. And inside of model base, in the render new, what Django does is it creates the class, and here super new is just super render new. It uses super new and assigns super render new to it for whatever reason. Then it does some other stuff, and here is the method.
Is it calling the superclass method?
Yeah, it's calling the super render new, which will be essentially type render new.
It will be the like superclass of this model base.
Yeah, so model base inherits from type. It's a normal class. It's the meta class of this model. Here is a typo. It needs to be meta class equals model base. Okay, sorry for that. So in new, what it does is it constructs the class, whatever model, Django model you want to construct, and then it adds the does not exist exception to it. It does a lot of other stuff, adds the underscore meta stuff to it if you ever use that. And finally, it adds the objects manager. We have all used that. We all love it. So without this stuff, it would not be possible. And then it also, there's a lot of dots here. I missed them. I don't know why. This whole class is really, I think 400 or 500 lines. I wanted to present a lot of stuff, but it just doesn't fit on a slide. But I hope you get the idea. Okay.
So what is Django?
Yeah, Django is a web framework. I'm sorry you're not familiar with it. A lot of people are here. Yeah.
So why are you giving Django as an example? Is it using web application framework?
Yeah, this is the source of the framework.
This model base?
Yeah. This is right from the Django source. And I'm just trying to show how they've used metaclasses. Okay, so this is a really crazy example, I must say. perhaps the most insane usage of metaclasses I've ever seen. And this is from the book Fluent PyCon. Really nice book. And okay, do you think this will run fine? This class flavor and just bananas and coconuts. No one expects it to run. Everyone expects an error. And yet it does run fine. Okay. So there's some really insane metaclass stuff here. But we've discussed all of it. So you could do that if you want. I'm not going to present all of it, but essentially it's really small. Okay, so this is essentially where the magic is happening. Autoconst is here. It declares a meta class, so flavor gets the same meta class, which is autoconst meta, and all the magic is done in this prepared. Okay, and so when Python tries to process this, it uses this widely decked object whose internals I'm not showing. It's really small. All it does is that once Python is going to look banana on inside of this widely decked instance, it's going to, inside of the get item of widely decked, if some key is not found, it assigns it an auto-incrementing integer. So banana will be assigned 0, coconut will be assigned 1, and vanilla will be assigned 2, and all of this stuff works. Okay. Yeah, so that's really crazy. When I looked at it, I didn't even expect, I wouldn't expect something like this to even like run without some sort of, error, name error, something like that. But it does work fine. And no, it doesn't raise because of this widely decked magic. Yeah, so essentially this is not really what this does is this is banana and this is just a name in Python, right? And so the crucial thing to note here is that when Python is evaluating this banana, it's going to look at the local namespace, okay? And the local namespace is this widely decked. This is not your normal dictionary. This is a crazy dictionary. And so it's going to say, hey, widely decked, I want to get banana. And widely decked says, okay, I don't know about banana, but I'm going to assign banana 0, and I'm going to give it to you back. Okay.
We are affecting the name switching of the Python and the collection depends on the name.
Okay, no, this is not going to affect it. The garbage collection is going to run fine. Okay. This namespace is only valid inside of this class definition. So this class uses this namespace. Outside of this class definition here, elsewhere, you will have your local namespace. Okay. So finally, an example, the last example, I think. Yeah. So data classes, ident stuff. You're probably aware of this stuff. So who has used data classes? No. So you do stuff like this. You define a class. You add in some type annotations. And the magic of the data class is that it just magically adds the render init, wrapper, hash, whatever, a bunch of magical functions. And you can do this stuff. In the standard library, it's done with this decorated data class. But if you don't like decorators, then you can do it with the meta class. Okay. So this is just a usage of the sort of stuff you can do with data classes. Okay, so here is a data class, meta class. Interesting. So you define the render new, and in that you just create init, wrapper, and just add it to the namespace of the class, and it works. It works fine. And how you will use it? Metadata class will specify this data class as its meta class, and then simply you inherit from metadata class, and you can do all of this stuff. So instead of this decorator stuff, you are just going to have to inherit from this metadata class. Yeah.
If we were to create a custom decorator, then will that still be like a metaclass or have a discussion?
No, a decorator is something different. This is This is a decorator here. Okay, so the decorator gets passed in a constructed class, and then you add some stuff to the class. Okay, so a decorator is roughly equivalent to, like, if we were to have an dunder init in the meta class. So that's roughly equivalent. Fine. Yeah.
So what's gonna happen if you add 2 or 3 instead of 1?
That depends on the data class interface. I would say that I'm not sure. You'll have to try that. You'll probably get it, and you get an error. I don't think you'll get an error. I don't think you'll get an error. So type checking in Python does not happen at random. So you have to run the type checker when you're writing code, and at runtime there's no type checking. I would expect it to work fine, but I'll have to try. I'm not sure. we can try after this, okay? Type checking does not happen at runtime. Okay, wrapping up. Metaclasses are useful for class customization. We also saw where you could use it to control the behavior of the instantiation of class instances or objects, whatever you want to call them. Somewhat hard, I hope not anymore. There's many other ways to customize classes. Decorators, like the data class decorator does. And then there is dunder init subclass. These are special methods that you define on the class, and in fact these two methods, their init subclass and set name, they were specially added to Python just to make it easier to use some of the features of metaclasses without having to know about them. So the desire was that a lot of people don't know about metaclasses, but still using them can be helpful. So we add an easier sort of metaclass-like API. There's also class getItem. And with all this stuff, metaclasses are still the most powerful. Okay, they can do all of this stuff too, but they might not be the most, easier to understand. So some references that I used to prepare this talk. You might find them helpful if you want to learn more about metaclasses. I guess we can take some questions.
Okay, so in that slide, when you gave the example of data class and you made it through, through a meta class, if you can go back to that, I had a question about that. So you first created this, normal class and metadata class right there.
Yeah.
Couldn't you just directly do it in name, or is that middle step needed?
Okay, so you want to do name metaclass equals metadata class? Yeah, you could do that.
Right.
This is just a nicer interface, I could say. That's how you'll find it in almost every library that uses metaclasses. In Django, even you do inherit from stuff rather than define the metaclass directly. So it's like the abstraction is like hidden from the users.
So when we go back into inheritance side of things, so in Python we can have like multiple parents in the inheritance. So how does the type calculation work at that point?
Like that, yeah. So I think we had a slide regarding that. Yeah, metaclass inheritance.
Yeah. So let's say.
Yeah. So if child inherits from parent and a lot of other stuff.
Yeah.
And they inherit
have
from a lot of
different
other stuff.
metaclasses.
Yeah. So the thing to note is this. So say child inherits from parent and grandparent. Okay. So parent will have a metaclass and grandparent will have a metaclass. And you look at the inheritance structure of those metaclasses and you choose the least, okay, essentially. So you choose the most derived of those. If there is none of them is the most derived, it can be that they appear at the same level in the inheritance tree, then Python will throw an error. Okay. I won't say it's the rank. But you'll get an error, okay? In cases like that. It will be metaclass conflict, something like that.
So, what is the relationship between abstract classes and metaclasses?
Yeah, so you can implement abstract classes using metaclasses. In fact, that's how it's done in abc.meta if you use that. Yeah. So you can implement that with all this. Yeah, I wanted to put it there, but it was really hard. I looked at the source; it was hard to extract reasonable snippet to put there.
So in this case, which one is classy? The class is for the child.
Class C.
Given a class C.
Yeah, C is right.
C's child is like the most derived class. Most derived.
In this case,
Most superclass.
the derived is like at the bottom. So, like
So it's most derived class on the metaclass.
of its basis.
What does
What does this mean? We don't have chalk here. I'm sorry, we're out of chalk. Okay, so like if you had a grandparent here, okay, and then parent would have a metaclass, grandparent would have a metaclass. If you don't specify metaclass, you get typed as a metaclass, right? So here is parent's metaclass, and here is grandparent's metaclass. And now if there is some sort of inheritance between these two classes, so imagine that this one inherits from this, then this will be the. And if this one inherits from this, then this is the metaclass. And if none of them inherit from each other, then you get a conflict, you get an error. Python will not allow that.
so parent is the metaclass or the grandparent? In normal.
So the metaclass will be meta here.
So meta is the grandparent of the child class, right?
No, it's not the grandparent. There is a metaclass relation, and there is the subclass or inheritance relation. So you have to think of them as separate. Yeah. Any more questions?
I have a question. What if we want to have a metaclass chains, multiple metaclasses for a single class?
You cannot have multiple metaclasses for one class.
What if we use mixing?
No, you cannot mix them.
We can have that, but it won't make sense. Like,
No, you cannot have multiple metaclasses for one class because metaclass is like you call type child and it gives you the metaclass. So you can't have multiple results. Okay.
okay, yes.
It won't do another if it can find a most derived class amongst the metaclasses, but if it cannot find a most derived unique class, then it will try another. Yeah. Yeah, you can declare. The type of child is this meta here. Totally changed? I don't understand. You need, okay, so you define some method here. So you can do just like that, child dot.
So if we can get all the methods even though
It changed from type, even though you've defined a metaclass, everything works fine. You can just fire up a REPL and test some stuff. Okay? It's always helpful to like write some code, test things out.
So I think that's it. Now we have lunch, so we need to move forward with the lunch.
If you have any questions, I'll be around today, tomorrow also. And if you have any feedback on the talk, I'll be happy to take that.
So,